All right. Good morning, everyone. Good afternoon. On when you're watching this, this is Geometry Lesson 9.1 notes on reflections. So our objectives today will be to draw reflections, as well as draw reflections in the coordinate plane. Okay. So key concept here, we want to talk about a reflection in a line. So this won't be in the coordinate plane. This will be just a reflection across the line. So a little bit of vocab. Line K is the line of reflection. So in both these examples here, we're reflecting a point across the line. So a reflection, so we're going to read here. A reflection in a line is a function that maps a point to its image such that, first case here is if the point is on the line, so we're looking at this example here, where point A lies on the line. So if a point is on the line, then the image and pre-image are the same point. Or, next example here, A is not on the line. You can see that the point A is not on line K, not on the line of reflection. So if the point is not on the line is the perpendicular bisector of the segment joining the 2 points. Okay, so the line K is a perpendicular bisector of the segment that joins A and A prime. So it bisects that segment as well as it is perpendicular to that segment. All right. So let's scroll here a little bit and let's reflect a polygon in a line. Okay. We're just going to reflect each vertex. We're going to reflect each vertex, A, B, and C, across the line. So we're going to reflect the point A, we're going to reflect the point B, and again point C. So in order to do this, you'll need a ruler or a straight edge. A ruler's most useful because you can get a measurement with it as well. What I'd like to do, set up the ruler so that it's perpendicular to line K. Again, perpendicular means it makes a 90-degree angle. So you can kind of put your ruler there on point A. That's not quite 90 degrees. Again, we're trying to be perpendicular to K. So perpendicular to K. It looks like my ruler maybe at about that point. I think that's about a 90-degree angle. Again, I'm not going to be too technical here, but I believe that angle right there, sorry. That angle right there, that's about a 90-degree angle, I would think. So, so we make our line perpendicular to it. Okay. We're just going to draw across because we're reflecting across K. And what measurement do we get? How far is K, or how far, excuse me, is A from K? Well, it's, if this is the centimeters, it's about 1.7 centimeters from K. So when we bring our ruler, we actually want to pick up the ruler, we want to bring it down here. We want to measure 1.7 centimeters from K. So 1.7 centimeters puts me about right there. Okay? And so this point here, this new point that I have, that's the image of A, that's point A prime. We've reflected A. And then we just repeat this process here for points B and point C. So again, we want to be perpendicular to K. Again, I believe we're about perpendicular there. And so we draw our line. Okay. That line, I would think, is perpendicular. We get the measurement. The measurement here, it looks like about 3.1 centimeters to me. Or about 3.1 centimeters from K. Okay, 3.1. Good estimate, at least close enough. And then so we come down and we measure 3.1 centimeters away. And put point there. So that point is the reflection of B, so that point is B prime. And then we would do the same with C. You can make your perpendicular segment and get a measurement. So the perpendicular segment here, there. The measurement, maybe 1.2 centimeters, it looks like to me. So we measure 1.2 centimeters. And goes there. They're about. point C prime, that's a reflection of C. And then if we connect all of these, that is going to be the reflection of the polygon. So make this look really good. Use your straight edge for that part too. All right, but that's the reflection of the triangle ABC. Okay, nothing too tricky there. This example, you guys would reflect triangle PQRS across the line in, and you guys can go ahead and do this example on your own. I'm not going to use the ruler here to do this. I'm just going to kind of guesstimate. So after you've done this one on your own, you come back and your triangle should look something like, which is polygons, four sides. So the point P would probably end up over here. P prime. Okay. Q is going to reflect across the end, so Q would reflect across to this side. And here I'm just estimating. Your guys is probably going to be a lot more accurate than mine. That'd be point Q prime. R, if I'm going perpendicular to N, a little further out than Q, so that's R prime, and then S, the last vertice. That's going to reflect maybe somewhere S prime there. That would be the polygon reflected across line, and you should have something that looks very similar to that. All right. Again, use your straight edge, make that look sharp. Okay, look a little better. All right. So now let's talk about reflecting a figure in a horizontal or vertical line. So triangle JKL has vertices 0, 3. So let's plot this thing. 0, 3. That's point J. K is -2, -1. J. This is K. And then L is at -6, +1. L. Okay. We are told that X. Okay. We want to reflect this across the given line, which is X equals -4. So if I drew the line at, let's draw our line of reflection, X equals -4. That is a vertical line. And I think reflections in the coordinate plane are a lot easier. You don't need to measure. You don't need to use your straight edge here or realize what's perpendicular, because if we're reflecting, I want to use blue to do the reflections. Let's see. How far is J from my line X equals -4? J is 1, 2, 3, 4 units to the right of my line of reflection. So if I go 4 units to the left, 1, 2, 3, 4. That is going to be the point J prime. The point, what would that point be? That point would be -6, 3. So, -8. 3. -8, 3. Excuse me. All right. And then point L is at -6, 1. Well, how many units is L from the line of reflection? X equals negative. L is 2 units from the line of reflection. So we need to go 2 units in the other direction, and there would be my point L prime. K is 2 units to the right of my line of reflection, 1, 2. Okay, so I need to go 1, 2 to the left, and there would be point K prime. So connect J prime, K prime, L prime, and the blue figure is my reflection. So again, I just counted how many units I was away from the line of reflection and moved it to the other side. So the coordinate plane is certainly a little easier than using that straight edge. I believe here we're reflecting the same triangle, JKL, but now we're going to reflect across the line Y equals 2. So if we recall where those points are, J was at 0, 3. I'll use black again here. So 0, 3 is point J. J. K was at -2, positive, -2, -1. This is the same points from last triangle. And then L was -6, positive. And we are reflecting it now across the line. Yikes. Now we are reflecting those points across the line y equals 2. The line y equals 2 is what type of line? Well, that's a horizontal line. Y equals lines are horizontal, so it's there at positive 2. So the red line is our line of reflection. Again, and accordingly, I just want to know how many units am I away from my line of reflection? Well, J is 1 unit above my line of reflection. So let's go 1 unit below the line of reflection. There would be the point J prime. K is 1, 2, 3 units below. So I need to go 1, 2, 3 units above my line of reflection. There's K prime. And then L is 1 unit below the line of reflection. So I need to go 1 unit above. There's the point L prime. And that triangle is the reflection triangle JKL across a horizontal line. To reflect in the line y equals x, so this is not a horizontal line, this is just the line. If we look at the coordinate plane, the line y equals x is the points, it's got like 0.11, 0.22, right? -1, -1. This is that line, y equals x. So to reflect in this line, the y equals x line, it's not horizontal, it's not vertical, so this is we have a pattern for this. All right, so to reflect in the line y equals x, we're going to change a point xy to, you're just going to flip the ordered pair, become a yx. All right, so example, if I want to reflect the point, let's look at the point B here. I want to reflect the point B, -1, 4. To reflect it across y equals x, I just reorder the ordered pair. The x value becomes the y value. The y value becomes 4, -1. So that's the point. And that's what you see here. Same thing happens with A. I had -5, 2, so I went 2, -5. I just reordered the ordered pair. I put the x and y values. Interchange the x and y values. So, nothing too challenging there. Let's take a look. Let's do this. Quadrilateral JKLM has vertices 2, 2. So the point J is at 2, 2. K is at 4, 1. L 3, -3. 0, -4. So this is the point J. The point K. L. And come here. Sure it's just trapezoidal. Well, it is a quadrilateral. All right, so we want to reflect this across what line? The line y equals x. So again, that's not the horizontal line, that's this line here. It's the one that has points 1, 1, 2, 2. That line. So the line of reflection is the line y equals x. And again, so to reflect the point 2, 2, I need to get J prime. I flip the ordered pair. When I flip the ordered pair, guess where I'm at? I'm still at the point 2, 2. So J prime is at the point 2, 2, which makes sense. That point lies on the line y equals x. So it doesn't really move. Okay, it's not wanting to work. I gotta work with here. So. There we go, J prime. It's still there. It's on the point. Use red for 5 points here. Point 2, 2. All right. So what about point K? Well, point K was at 4, 1. So to reflect it across my line, y equals x again. To get point K prime, I just flip the ordered pair, so it becomes 1, 4. So if I go to 1, 4. There's the point K prime. That is reflected across the line y equals x. Okay, what about point L? Point L was at 3, -3. So when I reflect it across y equals x, my point L prime will be at Put the x and y value, negative 3 comma 3. Negative 3, 3. That is our point, okay. Lastly, with the reflect point M. Point M is 0 comma negative 4. To reflect that across y equals x, just flip the order pair, so negative 4 comma 0 is the point. And try to connect all of these. This quadrilateral is our reflection across the line y equals x. Here's just a review concept summary of reflection in the coordinate plane. So reflect horizontally, vertically, and then reflect in the line y equals x. All right, we'll work on this assignment. You guys can get a head start if you'd like, but we will have time in class tomorrow to work on that assignment. All right, everyone have a great afternoon. Appreciate your participation.